we'll jump into this R script that's on the handout, and some of the data sets are on the R Canvas page. So I didn't send them out before, but they're available there. So at the beginning, I'm going to set the working directory where I have this R script and the other files, and so that's the first thing. First data set is about the Rock and Roll Hall of Fame. It's a CSV file, and Excel includes the name of the inductee, ABBA, AC/DC, and everything, all the way down to, at the end, ZZ Top and Frank Zappa. Right? And does the group have any female members, yes or no? The category, some people get inducted as performers, non-performers, and other things, and the number of people inducted in there. So that's the basic data set. And so you can import it into R a number of ways. If you go to, let's see, the second import option it's mentioning there. So if you go under File, there's an import data set. And the second one for text, I'm not going to update the package here that it asks for, but it would create an interface screen where you would see the data and try to read it in. I'm just going to read it in as a CSV file. This thing has 303 rows. It's often good to look at the first few rows to see what's there, or the last few rows of things to see if there's not any missing data or extraneous stuff. Some of these variables, like the number of female members, could be tabulated. It was yes or no. So 47 yes, no. The categories, early influence, and so on. It's often good to, R has different types of variables. It has numeric, it has character, it has something called factors. And so this one has some different levels of categories there. Actually it's not null, it has categories. This seems to have been done differently than it was when I first did it, so it is actually this time read in. That's going to be kind of interesting to see as different categories. Those things don't necessarily, we'll kind of deal with some of those things later, but that's just kind of there. So say we want to identify just the performers. Well, there are, hi, how are you doing? Good. Glad you could join. Here's the deal. So the R script stuff that we were going through. So the R script and some of these data sets are available on the R Canvas page.
Okay.
That was linked in there.
Uh-huh.
And so what we've done is, start R and set the working directory to a location where I have some data sets and so on. And I've read in a particular data set that's on people in the Rock and Roll Hall of Fame.
Uh-huh.
Right. This is from the Locke et al. Textbook. So the groups, the female, yes or no, categories, and number of people. And so this first thing is about, how would you identify the performers or create a variable to make it easier to just summarize the performers out of this, right? So one way to do it is to set up a variable or an indicator that says who the performers are. So initially, I set up just a variable P to add on to this that is always false, right? Then I'm going to go through with a little loop here through each of the rows, and if that person is a performer, I'm going to change the value of P to true. Right? So this illustrates changing, setting up a new variable, but also a loop. Right? So in this 1 to the numbers of rows, the number of rows in this Rock data set is 303. Up here in this environment data place, it shows that for us. And that 1 colon gives us the numbers 1 through 303. So a loop, this for loop, you give it some index number I. That's the thing that's going to be changing. And it's going to change through the list of things that's over here. Right? It's going to go 1, then 2, then 3, and so on, all the way up to 303. Right? And so inside these brackets, it's going to do something. There's an if a question in here. If the rock category for person I, for row I, is equal to performer, and there's a double equal sign there, meaning is it equivalent to. And if it's true, then it does the thing inside of these brackets, right, the first brackets. And it's going to change the value of capital P at location I to true. And that last bracket closes off the loop. So it runs through all of those. It doesn't take any time. And so now it's created, move this over here a little bit. Yeah. Now it's created a new column that is P. It shouldn't be, P is false. Let's see. Okay, there. I don't know where that other P came from. But anyway, so there's trues and there's falses, and they correspond to whether it's performer or not. So now if you wanted to do something like the, a summary of the number of people in the rock group where the performer is where it's equal to true, right? You can do that, and it will select out just the performers. And those are just the performers being summarized there. Because that P is true or false, you don't actually have to say, does it equal true? If it's true, it'll keep it, and if it's false, it won't. So you can just simplify things a little bit there. Oops, rock P. I should do all those things. Well, we're just going, maybe you can't do that. Maybe you have to say, is it true or not? So that's one way to kind of indicate it, create this true-false vector. Maybe it doesn't like this because of this thing is up here with quotes. Let me take those quotes out, right, and rewrite it. Now it just overwrites P, it doesn't create a new column, so now it has true or false. And can I do my little thing here of summarizing those people? Now I can do it. I made a little error. By putting those quotes in there, it created a character false, right? What I really wanted was a logical false. So it's just a little difference. And now this true is, the logical true or not. You can do a table of that thing, of that variable P, and there's 206 who are performers, 97 who are not. Now we're just going to go through a couple other ways that you might do that. Instead of doing true false, you might give it numbers, right? Maybe 1 for yes and 0 for no. And so the thing that this one has done as opposed to that, instead of doing a loop, you can actually do it all at once. Right? So this statement in here saying is the rock category equal, double equals to performer, right, really is doing that entire loop over all of them all at once. It does it element by element so that it does all the performers. It doesn't do them one at a time. And so it starts out with everything being a 0, and then it changes it to a 1 if the rock is performer. And we see in here, right, looking at it, let's see, what could I do? I could take, to make it a little bit easier to see, I can take out the first column. I'm going to take out the first column to make it a little bit shorter. And now you don't see what the rock group name is, which is not any fun. So maybe I'll take out the second one. Kind of fun to see the names. And the second one, where it's true, there's a 1, and where there's a false, there's a 0. So now 0, 1 indicates that. If I wanted to summarize the rock number of people, I can do it by this rock P2 is 1, right? And now do the subset and get it that way. Things might be indicated differently in different groups. So taking 2 times the 0, 1 value minus 1 changes it to 1, negative 1. Maybe somebody would do that in a data set. An alternative would be to just make it blank for everybody who is not a performer, and then everybody who is a performer, change it to a label performer. And now there's blanks and there's performers, so you can really do a lot of changing how you want to indicate that, and then select just those individuals for that. that indicator for what they are doesn't actually have to be on the data set itself. So you could create that outside, right? So if you created a new variable that is the rock category equal to performer, right? Well, let's say we're going to just make it blank, and then we're going to change performer where the rock category is performer to call that performer. These two things together create a new object. So now it's popped up here as a new object. Performer just has 303 values, whether it's either missing or it's performer. And so I can take something outside of the data set, rock, maybe if we want to summarize the rock number of people, we can just use that for performer thing equals that. So we can select within a data set by another variable that's outside. It doesn't all have to be attached like that. So, oops. This is giving me just a little performer. Did that run? Let me just double check it again. So, oops, I started to do something. Let me get that out. All right, so it's all in A. So that's.
It also says performer.
Oh, okay. That's why it's going to be that, right? So there we go. This summary has, because those other in A's were 97 that weren't used. So if you spell it right, then it still works. Right? In this P4 one, right, here's the table. Right? 206 and 97 is listed out here. The way it was done up here, this empty quotes here is kind of a character, considered a character variable. And if you table it, it gives a blank 97 and 206 that are performer. And if you add up how many times does that P4 equals perform, you get 206. How many times does it equals blank, you get 97. So that empty category is a category it keeps track of. Right? But what if the data are a little bit sloppy? So I'm going to set a random number seed because, well, I'm going to simulate a little bit. I'm going to randomly change some data to illustrate what happens. That random number seed thing is if you set it, the random things you do can be replicable. So if you reset the random number, you get the same sequence of events that happens afterwards.
Mine's going back up just for a sec. I missed the
this part?
rock category.
Right. I can upload as well an updated version of this to get details, right? So what if it's a little bit sloppy? I'm going to set that for today's date, 2019, 20/02/28. Maybe I'll do that. Maybe I'll make it February 28. And create a new rock P5. Right? So it's performer, but I'm going to change some of the performers to space performer. I'm going to randomly sample between them and change some random number to that. And I'm going to change some of the blanks to NA or blank space with a space in there, right? It's going to change it a little bit, right? Now there should still be 206 performers and 96 non-performers in the data set. What happens if I tabulate it after I make those little random changes? We get this, right? It has 37 with some category you can't see and 35 with some category you can't see and performer listed twice. There's 303 rows, but if you add up the numbers in that table, it's only 278. So not everything even got reproduced there. There were some that were these NAs. You can force tables to report NA as a category, missing is as a category. And so there were 25 that weren't actually even reported. If you add those numbers up, right? You can't actually ask how many of these rock people were performers. It does that the NAs kind of screw that up. So how many are performers and how many are not missing? This is .NA asks, is it missing or not? Right. And the negative here, this exclamation point means negative. So there's actually 95, 108. I must have changed the numbers. Let's see, should it be 108 that are performers? Oh, okay, that equals exactly performer like that, right? That's what they're random now, but does it equal performer? Let's do, in asking these questions in R, it uses this Boolean logic. So is it rock? Is the P5 equal to blank performer? Right? Is it one of those two things? And is it not missing? If you run that command, it gives you the 206. So that's what we would want. So the point of showing this is that at many times, data that are entered in a spreadsheet or sent to you that have character labels for things, if they have extra spaces, or if they're supposed to be blank, would have a space in there, get you slightly different versions. So it's a little tricky to check that you have accurate data. There are some commands that can help. So there's a command called unique. Right, so you can look at kind of the unique values on that P5 variable. Right? If you run that, aha, there are blank performer, a space, no space, and NA. The unique values get listed out there. So if you tabulated things and it looked funny or didn't quite add up to what you expected it to do, there might be missing values, there might be other blanks of certain sorts to deal with. This is harder to deal with if you have many different if you are supposed to be recording things for 6,000 people, and they could be in any of the 50 states plus the District of Columbia. Well, there's many different ways that things get reported. In some places, like I'm originally from Nebraska, some people think the abbreviation is NB. And so you'll see an NB in there instead of NE. Right? Or DC can get reported D.C. if they're typing it in. And so sometimes you have to go in and fix values to make that work. So that's kind of one example of these things. Right? Once we have these different groups, we might want to summarize them by different things. Right? So, like just continuing with this, well, let's go on to new example because that's what's here. One survey I was involved with last fall, was a survey for the Veterans Administration, where I was a sampling statistician on it, picking the survey sample and allocations and some other things. And it was a survey about disaster preparation. They asked veterans people work for the Veterans Administration, are you prepared for disasters? Have you experienced disasters? Have you been part of a disaster team? And so on. And this is a subset of the data and a subset of the variables. And it's been anonymized in the sense that there's no personal identifiers in this. There's no way you could trace this to a particular person. And also this E5, which is, and region, which are geography, I randomly permuted those, right? So randomly sampled those. So you really can't tell for the other variables, if you knew what those questions were, question A3A, A3B, D4, etc. Even if you knew what those, and somebody's answered to a couple of those, you couldn't tell what region or things that they're in. So there's no way to match this up. For the survey data, there was a computer survey, and so they recorded how many seconds people took to do the survey. The answers to a bunch of categorical things, with some missing values in there. E4 was a question related to are they a supervisor or not. E5 was something about geography, which veteran service area are they in. And then region was region. Is the survey complete in the sense of do they answer enough questions? Is it complete? And how many questions do they actually complete in there? There were about 100 other questions that they variables, but we don't need to look at all those. So we're going to read that data set in. There's a nice command called list.files. So that would list the files in the directory, your working directory. Right? So when I wanted to type dr equals read.csv, I didn't want to type this long thing in here. So I typed list.files as a command, and then I just cut and paste this thing to put it in there. So for a big long thing, you get it accurately and don't have to type it. So if you read that in, the disaster, right? These are the names of variables that are on there, and the dimensions. There's 4,127 individuals there. Right? To analyze that, what I actually went through before is to, I could run this again, there's no harm in doing that. I want to change certain variables. I'm going to change the geography variables. Right? I'm going to change E5 and region. So I'm going to create an indicator, something, or just I'm going to create a list here, which variables. I'm just, WCHVAR is something I'm going to call just to refer to those variables. And then my DR, I'm going to change these two variables here by sampling from the population, from this data file. I'm going to sample the row numbers 1 through the last one, 4,127. I'm going to sample that many times without replacement. So that's just going to randomly permute all the data things. And I'm going to change those variables. I'm going to replace what was there before with new versions of it, just randomly scrambling. And normally you wouldn't want to do that for any reason, but it does protect the anonymity and you can't tell. So I'm going to run that even again. I'm going to order the data set by that E5, that VIN variable. You don't really need to do that, but anyway, I thought in case we want to look through the data set, we might do that. There's this variable complete. How many complete surveys? 4,026 complete surveys, 101 that were incomplete. So people started the survey, but they didn't get enough questions answered to be included in the analysis. There's completes and uncompletes. So how many questions did they complete? Right? We might want to see how does that break out by group. Right? So one way to do it is to select that group by saying is the complete equal to 1 or the complete equals to 0. And you can write out separate lines to summarize those information. So here's the first summary. Here's the second summary. So somebody who was considered complete, most of them did 48, 49 or above as questions out of the whole survey. Somebody was considered complete with only 40. And then for incomplete, some people did 0, others did 25, and so they did fewer generally. Some people got pretty close, with like 47 or 48, but they didn't quite answer a few key questions to be included. So that's 2 separate lines for doing that. There's a way to split data by different categories. Right? Split will take all of the completed questions, this QComp questions completed variable, split it into a list that has by the values of complete, right, 0 or 1. Right? And so that will just create a list. This command sapply will apply a function to the split data. The function I'm interested in is a summary. So it's going to do a summary of the QComp when complete is 1, a summary of the QComp when complete is the other variable, and just give me the results. Right? So what does that do? Right. So it's done minimums, first quartile, medians, etc. by those different categories. Yeah.
So could you use split to create 2 separate lists?
Mm-hmm.
And would that just be, or I don't know if that's done in a second, but
Yeah, I don't show that, but what this splitting will do. So maybe we'll do it with a smaller case. Rock 2. So say we wanted to split that rock variable, the number of performers, number of people, and we wanted to split it by category. Right? And you run that command. It will split the number of people by category. And so what rock 2 is actually a list. Right? Looking at rock 2 here. So there's a list of the early influence, a lifetime achievement, non-performers, performers. So that's a list. This is something called a list. A list. And so you can pull off parts of lists by using this little double subscript. We haven't talked about lists too much or anything, but that's a different type of object. So the first one is all these early influence individuals, and you can just get them. To the performers, so dollar. What if you do performers? Is it just performer? Right, the rock 2, the performers, just is now the performers. So you can reference the different pieces of the list, and the split will break it out into these different lists. Right? But once it's split, things like this, if you want to apply a certain summary or a certain calculation to it, then this sapply does that. The summary command in R doesn't give standard deviation, which is kind of annoying. So one thing you can do is write your own function. So here's my own summary function. The function of x tells it's the function of x, and here's this argument. You can actually have multiple arguments if you want. And I'm going to do the summary, the standard deviation, and the IQR, and put them together. When I run that, it creates an object back up here, a function, my summary function. And so my summary, if you just type that, it repeats the function call that would happen. And if you put an x value in here, so my summary the rock to the performers will give me the minimum, medium, and so on from that function. Plus it will give me standard deviation in an interquartile range. Right? So I have my nice little function that I can apply when I give it a series of data. But you can also stick that function in the sapply. Right? So now I can apply my new function to all these different groups. Right? So if I run that, I get, there was complete surveys and incomplete surveys. And now I also get the standard deviation and the interquartile range. And the standard deviation for the complete ones is very small, because they typically had 49, 48 per 7, something like that. But there's a much bigger range variability among the ones that were incomplete. The value of looking at data, right? So as a seconds, well, when I summarize these things by comparison complete, there was this other one. Seconds was how long it took people to do, and I guess it's not in this analysis, but right. But there was the seconds. The histogram looks like totally kind of wonky here. The largest values of seconds are just enormous. There is one of these variables here. What I'll show you what I'm pointing to. That it was an online survey. So it recorded when did they log in versus when they logged out to complete the survey, and counted the seconds. Right? And so for a lot of people, 554 seconds, 60 seconds per minute, it's about 10 minutes. 10 minutes, here's about 20 minutes, and so on. Some are much shorter, 5 minutes or something like that. So that looks reasonable. But in the data set, there's a few values that are just completely unreasonable. Somebody in here was at 400,000 seconds as a report. To get that, I sorted the data and then took the tail end of it, so it's the biggest values. If you divide that by 60, you get minutes. If you divide that by 60 again, you get hours. So it looks like at the very end, some people logged in to the survey
and never logged out.
And never logged out till the next day or a few days later. So. And the smallest ones are kind of suspicious too. A few seconds, 3, 4, 6 seconds to do a survey. But maybe some of these people are incomplete. So let's look at just the ones that are complete. Well, some of them did the survey in a minute and a half or 2 minutes. So for 45 questions, like da 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 da, right? So if kind of just exploring, you learn a little something about it, and maybe you'd want If there were a few people at, 5 seconds and then everybody else was big, you might say, well, these couple people, that's just unrealistic, and I don't know how accurate the recording of seconds is, and if they could get into the survey and get back out and get in, if it captured total time.
Would they
or what.
refresh the page?
If they refresh the page, did it do something? I don't know. But in this disaster resilience survey, we might want to create a variable, right? So one of the variables is E4, is actually asking about supervisory responsibility, right? And the values of 2 and above had some, let's say that they had some supervisory capacity. Yes?
Is this the population subset DR?
DR, no, this is the disaster prep data, things like that.
Oh, so this is from before, sorry to interrupt.
Yeah. No, the population subset is just actually counts of population sizes employed in the VA in different places. This is just staffing information that eventually we'll want to combine with the other things for some purposes. But under here, we want to create that something to the supervisor. One way to do it is to just create a new variable that's 1. Oh, you found it? Okay.
Yeah, sorry.
And then when it's equal to 1, make it equal to 0. So write everybody's a supervisor except for the ones that give 1. Right? If you do that, and then check it with a table, and I'm going to use this NA, it's done something. Right? Initially, everybody got a 1. And that means that the individuals who, in answer to that question, actually that didn't answer, NA, right, got classified as got a value of 1, which meant supervisor. So that's probably inaccurate. So you need to be careful with that. One way to deal with that is if you call everybody a 1, and now if it's equal to this, or it's missing, if it's the first non-supervisory level, or it's missing, you can make it a 0, right? But now everybody who was missing originally is now called a non-supervisor. Maybe that's not accurate either, right? So if you make everybody a supervisor, and then if they have that they're not a supervisor, make them a 0, and then change everybody who is missing back to missing, now you have the people that at a level 1 on the first variable, they're non-supervisors, and everybody that's above is supervisors, and then the NAs are still NAs. So I think there's different ways to transfer these things. I always find it invaluable to check the tables match up when you're creating new variables, because it's a lot to remember and have in your mind how to do it precisely. And there's little variations in how this works, so checking works. Those 3 commands up there really can be reduced to 2. Right? If you take the supervisors and take 0 times that, then the table of DR soup at this point is all zeros, but there's a use NA equal, and there's still the 75 NAs. 0 times missing is still missing, so it's still missing. And then if you change the ones that are bigger than 1 and not missing to 1, it will achieve those 0, 1, and missing like before, but just with two levels. So anyway, you can create different variables. You have to watch out for the missingness in there, and it complicates things a little bit. And this type of stuff, is it doing these combined statements, is it NA or not? I find, or this one, is it NA or is it not NA? R seems to do funny things for some of this logic, right? If you ask a question, like is it equal to 1 or greater than 1, and there are NAs. Sometimes it will take the NAs and treat it as 1 and include it with that, or sometimes it won't. And I think it's much better to be explicit about dealing with it.
Is that because of maybe packages that you're running?
This is just running, I haven't really loaded any extra packages.
Okay.
This is just kind of the default
Okay.
way of going to it. So let me look at my notes just to see. So that's splitting some things, making some new variables. Right.
And does R treat true and false also 0 and 1 like Python, or is it completely,
It can be 0 if you make it numeric.
Oh, okay.
Right, so if you as.numeric, you can change things. So if you have some true, false, false, and make it numeric,
Right.
it changes it to that.
Right.
So if you do the sum, if you add up, go back to this. If you just add up the trues and falses, it's going to give you 1.
Right, okay.
Right?
Yeah.
Or if you take the negative of these things with a bang, it gives you 2.
Right.
So,
Okay. So, yeah.
So
okay.
yeah, it does. It
It does.
do that automatic conversion
Right.
for you.
Thank you.
And so that was kind of used in this one with 0, but it was, yeah, no, that wasn't used there. That's not in like more. So the next thing I wanted to say something about is just subscripts and how to do a few things. Wait, maybe not that one. Maybe that's where I didn't quite. What's going on in that? Oh yeah, no, it's fine to look at this one. So this E5 is a variable that it's VISN, V-I-S-N, a Veterans Integrated Service Area for healthcare. And there's many of them across the country. If you search at VA Healthcare, VISN, you get some maps, I believe. Yeah, so there's different locations across the country, and those are the VISNs. There used to be a number of them, then there were 21, now there's 18, so they've merged some of these together. Right? And so they're interested in how is healthcare or disaster preparation across different areas that might be dealing with different situations. Right? In this E5, tabling that variable, there's some blanks, there's don't know, null. Null means here this is actually written out, N-U-L-L in the data set. Right? It was a veteran typed N-U-L-L on the computer and sent it. Or they just, it could have been NA, nobody was blank, it was recorded these other ways. And look, it goes 1, 10, 12. It's not a numerical variable anymore, it's a character variable. So after 1 comes 1, 0, 1, 2, 1, 3, and things like that. And then 2, 2, 0, so it's not really like we might like to use it to refer to these things. And plus, really, blank, don't know, null, really means missing, or we can't do anything with it. So I'm going to copy that over to VISN, and then try and change it. Right? One way of picking out things is VISN. You can pick it out in a range. So you can say, does it equal blank, or does it equal null, or does it equal don't know? But there's this kind of cute thing here. Are the things in VISN, are the 2,000 or 4,000 some values of VISN, are they in this? One of those. Right? Is it blank, null, or don't know? And then it's going to change all the ones that are true to perform to NA. And if it's not true, it's going to just leave it as it was before, right? Unchanged. Right? So that will do all of that all at once. Now the table has these. So these have been zeroed out, those categories. NA has been 159. If you added those numbers together, blank, don't know, and null, you'd get 159. But they still don't know 0, null 0, that 0, and it's still character, right? So it's kind of concentrated them all in the NA, but it's not quite everything that you would want to do. If you do a table, okay, I just did that. Is VISN character? It's actually not even character, it's something called a factor, right? And so a factor is an ordered categorical variable. Right? So if you had a response to a survey that was, strongly agree, agree, neutral, disagree, strongly disagree, you wouldn't want that just to be in alphabetical order. You'd want it to be ordered like a factor. Right? And the factor variables are categorical character data, but in a particular order. And so this one has, not only is it character, but it has this extra factor on it. So to change that to a number, I find it advisable to change it to a character. Get rid of the factor levels, all right? And then, so now we have it like this. Now it's character. The thing that this has dropped, this is the other one, is these null ones. Don't know, null, and blank had nobody in them. When you change it, they remain when it's a factor because it was a factor level, right? So there could be a response here, and we know that, so we're going to put it in the table. When you take those out, then they're gone. Then if you change it to numeric and table, now you have 1, 2, 4, 5, 6, and so on in that numerical order. Right? So, right, so this response to this question, there was a few categories to put together, and then changing it to a numerical thing is before you could use it makes it easier to deal with. There's this population data, and so this next example was going to be using this, right? And so what this is there's a population file. In the different VISNs, there's a population size, and then a sample size, and then that was a sample percentage. And it was designed to be differentially sampling to get about 65, 6250 per region. Right? The VISNs are within regions, and so that's how the sample was set up. Right? But in survey sampling, we often create survey weights, the number of people in the population divided by the number that actually respond, to kind of view kind of an expansion factor. If we needed to expand the respondents to represent the entire population, it's captured in something called a weight. So we're going to, for each person, calculate the population in its VISN, which is given by these numbers, divided by the number of respondents. We haven't tabulated that yet. We need to tabulate from that data and then do it by the right locations. Right? So I read that in. There's this read Excel thing here, that this package for doing that. In general, you wouldn't need to do this. If it's on your own computer, there's this read Excel option from import data. Right? And if you click on that, then you can select that Excel data set, and it will present it to you, and you can read it in. I'm not going to do that because I'm on a lab computer and with a classroom computer, and I don't have read-write permission on all these directories on this computer. The way to get around that is to tell it what a library location for someplace you control, and then read it in. So I'll make sure that's running, and then does not exist. Path, our location. So let's see now. Let me see. List.files. Did I change the name of this? Population subset. Oh, I did change the name of that. Right. So I'm going to get that out of there. List.files. I'm going to copy this name in here so that it's accurate. Right, and I get my population. Okay, whatever. The first 3 rows of that population are this. VISNs, in, so on. You just type it as data frame of that. See, R sometimes gives you extra things, and it drops a little bit of this extra information. So the capital N, the lower N. Because I've done read Excel, it's been smart. Instead of having, it was a 17,000 with a comma in the middle there. Because I'm reading from Excel, it understands that that's a number. So it's been smart and made it into a number. Right? These are the first ones. These are the last ones in here. These other ones, there's only 4 regions, so it didn't go down so many rows. Right? That stuff is in there. Initially when I did it, I had 1 extra row. I've taken that out of the Excel file, so you don't need that anymore. Right, so I've read that in, right? And now I want to create my survey weights. So a challenge I have in this is that in the population data set, the visins are capital V01, capital V02, something like that. Right? But in my DR data set, my visins are, well, there's some that are missing. Maybe I'll just go out here a little bit further on and look at to see what's there. Oops, too many variables. Right. The visin numbers. Oops, get out of that. The visin numbers. Here's visin 1. They're just numbers. They're not character. Right. And so if I try to say, does the visin number equal this? I have some things that are numeric and some things that are character. So they won't match up. One option to do that is to create a corresponding variable in one of the data sets that matches in the other. Right? One way to do that is set up a character variable on the sample file. So I'm going to set that up. Now, if the visin is less than 10, I want to paste a V0 number and then the number that it was there. Right? So one way of referring to those rows, which rows do I want to do this to? Right? I want to do this to the rows where the visin is less than 10 and it's not missing. So I'm going to set up an indicator, a vector, called which row, WCH row. That's just the name I made up to refer to that. So that's going to be true where the it's a small number, an integer, and it's that, right? And then where I'm going to change the visin character in those rows, paste. I'm going to paste V0 and then the visin number. Right? And it should be a number like 1, 2, etc. With no separations. You can have separations that are space or a comma or a tab or different things in there. You can get help on that function here by typing help of paste. There's different explanations of things like that. So I'm going to run that. That should create that. Now if it's bigger than 10, I only want a V and then the number, right? Because I don't need that extra 0 in there. So I'm going to say which rows have visin greater than 10, greater than or equal to 10, and is not missing. I'm going to rechange that definition, and then I'm going to paste a V onto that. Right? And I'm do a table to check that I get the right thing. So in the left side here are the values of the visin variable. On the right side are the character version of it. So I get 1 goes to V01, or V01, 2 goes to V02, 4 goes to V02, etc. And then if it's V, if it's missing, it's still listing as V there. I'm going to do some, okay, we're going to keep track of that, right? So the point of that is we change those visins to a character that should match the other data file. So now what do we want to do? We want to set up some survey weights. So WTV is going to be my survey weight based on the visins. Right? So initially I'm going to set them all equal to 0. And then I'm going to go back, these vary by visin. So I'm going to go through the different visins. The population one had 1 row for each visin. Right? You can do integers here, like 1 to 3, 1 to 5. But you can also put characters there. It's just any set. And then it will index, it goes to that set. So I will go V01, V02, V03, going through those different things there. So which rows of my DR data set are this visin? So is the character equal to I, and is it complete? We're only going to put weights on the complete data files. And then is it not missing? Let me see. Is there any missing? I think I was running into a little bit of problems before. So let me see if this is, is the sum is.ina dr blank $, isn't. There are 159 that are missing, so I don't want to use those. Now, which row is a true false? If there's anybody in that character. So one thing that happened over time is there were 21 of these in the population originally, and then they reduced them to 18. They merged some. So the DR data set only has 18 levels. So if I try to do this with one of these other ones, it kind of runs into things. I'm trying to select rows when nobody has that value, and it gives me an error saying that there's nothing like this. So if the number is greater than 0, then I'm going to change the weights. The sum of the which row, it should be the number of respondents. Right? And this should be, I'm going to try, let me take this out and see if this works for me. It was giving me kind of an error before. So this population, say the first row, the second column, is a number. I really want that to be just a number, okay, as numeric. I just want it to be a number. I'm just trying to take off some of this extra formatting that R gives. And when I did it once before, it seemed to give me a little, didn't work quite like I want. So I run it, it does my loop. This, right. What type of weights did I get? Oh, they're all 0. That's not good. Maybe I didn't run these all the way through. Okay, I have those. Weight 0, populations, right, in the table. Why is it 0? It should be replacing, so the character equals I, complete equals 1, and it's not missing. So which row performed is relevant to 238? So why is that not going? Let's see, what was this number? In A. Why is that in A? So those are the things that should be going through. None of these are missing. Right. So I'm not sure where that missing is coming from. The value of I is this. Oh, okay.
It's the last one.
Yeah, it's the last one. So this has to be an indicator, right? So I've tried to use I as a numeric. VIN equals I. Right. Right. So this will pick out the row that equals the current I that I'm on.
So we want it as numeric, not as matrix.
We might not even need that. Let me get rid of that out and see if it just works fine. I was trying to fix something that was a different problem. So that looks okay. So if I run this, everything's set to 0. I go through my loop, it worked, and I table it, and I get a whole bunch of mess. Well, that could be, now this could be the result of as.numeric. Let me do as.numeric of this, and see if that likes it better, if it likes a number rather than kind of a more involved thing. That liked it. Right, so I get 295 times I get a weight of 29. 305 times I get a weight of here, and this was 0. Right? Another way of looking at S apply, we could split dr weight by dr visit. And we want to just, they're all going to be the same within a visit, so let's just report the means. So these are the average weights, because sampling weights were not quite equal. But in some places, the sampling was less, so each person represents more, right? And so that has created this new weight, right? So anyway, there's different ways of going about doing that, right? So we created a variable, we used a loop, we picked out certain cases, and then changed some things. We had to deal with, sometimes we don't want to divide by 0, so we kind of avoided that. Another way to rewrite this, now that I understand a little bit of what's going on, right, is if we go through just the rows, right, the number of rows in this thing is 21. Because originally in the population there were 21. These are not actually the survey weights. I would actually, merge the population in the right ways to get down to 18, and it would be a little bit different. So now, the i's are going to go through integers. Right? And now we're going to ask, is the Visin character on the data resilience file equal to the ith level of VISN on the population file? Right? So the previous loop was looping through characters. This one is looping through integers, so I refer to that one. So now I want to do pop. Now I think I can just do I. Right? It's going to be the ith row. I don't need to reference it there. So if I do this, it worked. If I do the table of the pop, of DR weight variable, it's giving me numbers again that match what was before. Right? So it's very flexible in terms of doing the indexing and looping through things to do calculations, but it has to be careful of what's an integer, what's a character, and how it refers to things. But in any case, so something like that was done in the actual survey. That's taken up most of the time that I was thinking about. There's tons of stuff to learn and do, and as you go forward, every once in a while, I want to just mention two things, right? Is there's these different packages, right? And you'll hear about different packages. So NLME is a particular package for doing linear and nonlinear mixed effects models. So an extension of linear models that allows random effects for groups or repeated measures is this. Right? There's but CRAN is this comprehensive R archive site. Right? It's a place that you can download. For any of these packages you see, there's usually a description at CRAN. And if you click on that, so it describes kind of what it is, some of the people who wrote it. There's usually a reference manual that will show you, the list of different commands and so on. And it's just, or the different functions. So this one's pretty huge. This is a huge package. Right? Some packages will have a dozen things, and this one has hundreds, right? And then it gives a different function. That's a little hard to read unless you really get into things. But that's a reference manual there. Sometimes there's different explanations of it. Sometimes if you just search for the package, so here's the package, our project, documentations, people have written descriptions of these different things. This is not the best one, I guess. The UCLA site about teaching statistics. No, maybe that's not. Repeated measures are, so sometimes there's different sites that deal with that. So that's not the best example of these, of finding information. ggplot is a package for doing graphics that's kind of popular. Again, there is a reference manual. There's also this thing for some of these called vignettes, where they will have a document where they describe how to use it, give different examples, right, of things that looks like kind of a little technical thing. Sometimes these packages that are out there have websites. Right, so it looks like there's a website for ggplot. People have documented different things of doing it. So as you're going along, if you see a book using that, or somebody's using that as an example, and you want to find out more, you can search and find some information. In terms of getting the packages into R, right, there's a packages tab over here. And it lists the packages that have been loaded. I haven't loaded all these myself. Sometimes I've loaded one package and it wanted another one, and some of these are defaults, right? But ggplot is not loaded. I haven't been using it really. So the first thing to do is to install one, and ggplot 2. Oops. Right, is the one you would pick, and then you install it. Click install. And it looks like it's trying to install it and goes through that process. Maybe this will work, maybe it's not. It said library was not specified, so I might run into the problem that I'm doing this on a classroom computer. But it's doing stuff. Right. Okay, now I'm still trying to get these things to go. Looks like one of these was successful.
I think it might be still running, right?
Yeah, it still might be doing something. But it usually doesn't take that. I'm going to press stop and go back up here to where I did the command. On this computer, I might, and I'm going to grab this, right, install.packages. Before I do that, you can do a help of install packages. So it gave me a little library. LIB is what I'm looking for. Install packages. I can tell the library to go to someplace I control. And I have my R location that I've been using for these things. So because I control that R underscore location, right, okay, it doesn't like it that way, it likes /. It can go tell it to install it in some place that you can control, so I can get around kind of the classroom business. And here we go again with that. But once it's done, then it's on my machine. Right? And I still have to tell R to actively use it. So I type library of that ggplot2, and then all the commands and functionality of ggplot becomes available to me once that gets done. We'll see if this goes. Well, and I think that this particular one is an example of one that has a bunch of different packages that are written that it's kind of brought in and uses those functionality. And that's one thing that's a little bit seems a little bit risky about R. You try to install different things, and if any of those things change or the dependencies break down, then maybe it won't work in the future. But I would experience minimal experience like that. So anyway, this seems to be working. It's just kind of time consuming. And so it's 1 o'clock. You usually have to go to a class about 1.
He knows I'm
okay.
here, so.
The last thing was going to talk about is that, one other kind of enhancement that I do when I do things in R and have they have this thing called projects over here. And a project is you start a new directory where you put all your R stuff related to one thing. So that worked. It's all there. So I would type library of ggplot2 or ggplot library. Okay, lib.location equals, tell it where to look. Location. ggplot2. Okay. So now it's there. So So there's a help file for ggplot, with help packages, package equals ggplot2, right? And elegant graphics. And there's some things there. So kind of as you get into it, you would learn more about that. This thing with projects, right now there's none. If you create a new project, well, I'm going to save the stuff that I'm working on. If you create a new directory and a new project, it asks you where you want to go. So I'm going to give my thing my new project name up here. So I do this like for homework. I'll have a homework 4 project, a homework 5 project, an exam 1 project. And so that our work and our files that I want for that one are going to be contained in this. So I'm going to do that, create project. And it kind of refreshes and starts things over again. If I go up a location, or go to this R session 3, and I open my R script in there, and I had saved a version of the R data in there, and then kind of have that going there, and then I quit the session. I've created a directory where is my new project here. It has this other R image inside of my directory here. If I click on that project, if I had done enough to save it, it pops back up with the R script loaded, with the data loaded that were there. So that if I want to switch projects, I don't have to have everything all in one big R directory all the time. The projects, you can create different separate ones that then have different things in them. So as you move from topic to topic, you can create projects. Now you can get by just having an R script and R data file saved in a particular location. The projects is kind of a convenient way to start everything. And I believe that some packages will start up again or load again for that library. So if you do some special things in that one, it will remember some of those details. But yeah, so that's kind of what I wanted to do, thought about doing. But any questions or comments or?
I just did a box plot of the seconds this
Oh, yeah.
a while back, and I mean, it's a line. There's not even a.
Yeah, almost
because
everybody's.
It's such a huge data point. It's.
Somebody left their computer on for a
everything
week.
Just, yeah. But I was curious about that, so I just scrolled back up.
Yeah,
to the
yeah.
box plot, but,
Right.
so.
So anyway, it's been fun doing these few sessions, right? I'm glad a few people came to see them, and so I think that it's giving me some thought that some of these topics that I'm kind of marching through because we're doing it kind of a limited time frame would be pretty easy to do a pop-up course where we do meet once a day, once a week for 10 weeks. Kind of about a quarter of a class or something like that, and have people do something for each time, like install R, do a little data manipulation of something, and so that it would stretch it out over a bigger time, and there's a little more time to do that. But any type of so any topics you would like to? Well, Amir, we can talk as well about things that we might put in that would benefit data science courses, statistics courses, and things like that, and other things. So that's what I have planned for now. But when I do some programming art, like stuff with surveys, I have to check variables, rename variables, recode things, check the missingness and all that. Maybe sometimes do loops to go through things, and sometimes it sometimes it gets a little more complex than that, but that type of stuff handles. Sometimes then you go and tell somebody who's doing a survey, did you know somebody was on this for about 5 days? Somebody completed this in 10 seconds. I'm like, what? Really?
Someone got really stumped by one of the questions.
That's right.
Stared at it for 7 hours.
Oh, hopefully somebody didn't have to go to the hospital and they come back a week later and, oh, I better finish that, right? Great, so,
Thank you.
yep, thank you. All right.
I actually had something like that a while back where I was playing a game on my computer and then I had to go do something, so I closed my computer and I didn't use it again for like 2 days. My friend actually called me and he said, "You've been on Factorio for 25 hours, you should go to bed." I was like, what? But I was just, I closed my computer and it was like, kept logging the hours, kept saying on Steam that I was
Yeah, I have a lot of hours on a game called Plants vs. Zombies. So, but it's one of these things where you get chocolate and give it to your little snail, and that snail picks up coins. And then you can leave it for 10 or 15 minutes. And so I'd leave it, and then the snail would fall asleep, and there's nothing harm, no harm in just leaving it there. So I go off and do something for a few hours. So at some point I saw somebody, "You've been on for 90 hours. What? No, I haven't been doing this. But yeah, here's Frank Zappa in the Rock and Roll Hall of Fame. Just him, so it's just one performer, even though he had
Yes.
big bands.
Right.
A dozen people sometimes. But in there.
Mothers of Invention.
Mothers of Invention. They're not in there separately. The mothers aren't separate. There's kind of a changing group. But I asked, look at some of the, so Grateful Dead had 12 people. The Grandmaster Flash. There's a number. There's somebody else that has more. 16. Who was it? Not Earth, Wind, and Fire, but we find kind of 16 in there. There was Parliament Funkadelic. So I kind of do that in class sometimes, and people say like, "What? 16? Who's Parliament Funkadelic?" Some of them maybe heard of it. I don't know, but anyway, kind of fun. Okay. Thanks.
Thank you. See you tomorrow.
See you tomorrow.